Penguins rejoice, we are back at it again with another Linux code review. Hey, what's up guys, my name is Cherno, welcome back to my code review series, a series in which I review the projects you send me. I thought it was time to please the Penguin lovers and review this seemingly really simple command line chat room. Dear Cherno, I hope this message finds you well. First of all, I'd like to thank you for getting me started with C++. It has since become my favorite language and I intend to work with it professionally. You're welcome. It's also my favorite language. I've been enjoying your code review series a lot and I finally have a little project that I think you might want to review. So we have like a super basic chat room where clients can connect and talk to each other. I'd like you to review the overall structure and logic of my project and my approach for various problems. Also, any advice for getting deeper into networking and related areas will be very valuable to me since I want to go in that direction. Also, the project can only be built on Linux. I hope that's not a problem. Well, you know what happened? So I was like, yeah, time to use Linux again. Let me just boot up my computer, my special Linux computer, which is like set up to dual boot Windows 11 and Ubuntu, only to find the Ubuntu partition was missing. I feel like this has happened at least 3 times to me somehow. So I was like, yeah, no problem. I'll just install it again. I'll partition the drive. I'll install Ubuntu again. So out comes the USB. If you don't want to hear my Linux story, skip to this timestamp. I grab Ubuntu 24 LTS. It's on my USB. I'm installing it. Suddenly, installation failed for an unspecified reason. I'm like a little annoyed at this point, but like, you know, let's just try again. I mean, I don't know what could have happened. It's pretty straightforward. I've done it before, probably more times than I would care to admit. So I run it again and this time it succeeds. Not a problem. So out comes the USB, I reboot and straight to Windows 11. Didn't bring up that little boot screen where you can select what operating system you want. Nah, just Windows 11. I go to the BIOS. It seems to be booting from the only drive that I have in that computer. So at this stage, I literally can't boot into the Ubuntu installation that I just installed. So out comes the USB once again, because you know, I need to boot into Ubuntu. And before you know it, I'm like running all of these commands, trying to figure out what's wrong with grub. I'm figuring out whether or not I need to be mounting like different partitions or like creating these files, hunting around for that EFI system partition. When finally I find this thing called boot repair, which, you know, involved me adding like a specific repository to apt and then like running this thing. I did the recommended repair and then finally we were in business. No, actually, I think one more trip to the BIOS and then we were in business. Anyway, this took me like the majority of the day. Obviously, I kept leaving it and then coming back to it and then leaving it and then coming. Anyway, not the best day of my life, but we're here. So if there's like this sort of tone of bitterness in me today, it's probably not the code. It might be, I haven't looked at the code yet. It's probably not the code. It's probably just life. Anyway, here is the link. I want to be game dev. Here is a link to the repository. I'll leave this in the description below as always. I don't know why I'm still holding this USB. The README looks pretty good. There's a bunch of stuff here. I'm going to probably cut to the chase and set up all of this stuff off camera and I will report back as to how that goes. It went okay. I was able to run pre-make just fine. Yes, by the way, I was surprised that this project uses pre-make and not CMake. But then when I went to run make, I discovered that there were just a bunch of C++ compiler errors because for some reason, and this is the diff of the Git repository because I had to change all this to get this to actually build, WSA, this was used, this namespace, instead of sock. So I think what must have happened is this person like decided to rename it, this minor naming changes commit. Yeah, so they changed this WSA namespace to sock, but then didn't update most of the functions. Or maybe they just forgot to commit a couple files. So I had to go through and also finish their refactoring for them. So, you know, mood is worsening, which have like a little display, like a little heads up display kind of UI thing that just shows like Cherno's mood and it's just like decreasing. I've got it open over here in CLion. We've got a bunch of different targets set up, the server and the client. We have server main, we have client main. If we try and run server main, we're gonna immediately get a segmentation fault. Yeah, that sounds about right. Now, we are running this through the debugger, so if we go back, we can see why. It's because we are expecting an argument over here at index 1. And there is actually something here that checks to see if argument count doesn't equal 2, because there's always going to be that first argument, which is the actual path to the binary. But then there's going to be an additional argument here that's required, which is the port of the server that we're starting. If this isn't given, then unfortunately this code will print out the usage, although I didn't really see it printed here for some reason. It's using printf to print out the usage, but it's then just continuing on and crashing, whereas we should probably have something like a return 1. I think I noticed over here in client main. Yeah, over here in client main, it's done correctly. We're actually returning 1, which is, you know, not a 0 return code. So that's just a way to indicate that something went wrong, which it did because we didn't actually run the program properly. Anyway, that's step 1. So if we just go ahead and add like port 8192, which is my little favorite port to use, and we hit debug, then it looks like we're listening for connection requests on, I don't know why the IP address is 0, but sure. So how should we test this? I think we should probably try and deploy this on an actual server. Yeah, why not? Let's pop this onto a hosting a server and we'll see if this actually works in a real environment. And I'll show you exactly how to do that using a VPS from Hostinger, the sponsor of this video. So Hostinger is by far my favorite web host on the internet because they have really high quality servers at really good prices. Their servers use AMD EPYC processors and NVMe drives for a really fast and responsive experience. They obviously give you full root access, which we are going to need to be able to do whatever we want. Couple this with strong security and DDoS protection, as well as excellent support and documentation, and things like the dashboard looking absolutely beautiful and a pleasure to use. It's just a recipe for something beautiful. Setting up a new server is super simple. Just head to hostinger.com/Cherno, pick a plan. All of these you'll notice are KVM plans for their VPSs. What is KVM, you might ask? KVM virtualization is basically a way for a VPS to function as a completely independent server. It's just a much better approach than using a container. And that's another reason why I really like Hostinger. So once you choose this KVM2 plan, for example, at checkout, make sure that you use coupon code Cherno to get an additional 10% discount. Once you've checked out, you'll be ready to actually set up the server, which again is a really simple process. There's a bunch of different locations to pick from. I usually pick the one with either the lowest latency to me or my clients, my users. There is a huge range of operating systems to pick from. I usually pick Ubuntu. That's what I'm running physically here in the office as well. And then finally, you just have to set a root password and you're done. It only takes a couple minutes for your new server to be ready, and you can just SSH into it and start using it. So if you guys need any kind of web hosting or VPS, I highly recommend Hostinger. Head on over to hostinger.com/Cherno. Make sure you use coupon code Cherno to get that 10% discount and go and get yourselves an amazing server. Huge thank you to Hostinger for sponsoring this video. So I've just SSH'd into that server using VS Code. Let's open up a new terminal. We've already built that server binary, so I'm just going to drag it into here. Now we can, of course, either upload the whole repository, just check it out using Git right here on the server, build it locally on the server. This is just a code review. I don't think we're going to be iterating too much or anything. Otherwise, I probably would do it that way. So for this, as you can see, I'm just going to drag that executable that we built on this local version of Ubuntu onto the server. Okay, so I'm gonna have to mark that as executable using chmod like that, and then I think we can just run it. We'll probably get that seg fault. Okay, so we did get that usage here, and then it kind of crashed. By the way, you can see that it doesn't actually give us a new line character after this, which is quite annoying. That was another minor thing that I noticed, but make sure with printf, obviously you are adding in those new line characters at the end. Otherwise, this kind of looks a bit weird. Makes me want to clear my terminal. So server debug, and then we'll put in the port A192, and looks like we are now listening for connection requests. I don't like that it's printing the IP address of like 0 here. I think that's a bit weird. I would either just print the port or get the external IP. So our external IP is written up here. It's 147.93, etc. In fact, let's grab this and we'll maybe try and connect from the client. So if we run client debug, it's going to tell us the usage again without the new line character. Let's quickly fix that. It's annoying me. So we've already done that. Let's just make sure that we compile. So let's add in the new line for the client. We'll just make sure we build all of our configurations. And then now if we run this, there we go. That's better. Okay, so 147.93.81.195. Port is separately here, 8192. And let's do username Cherno. Okay, we're in. This says we've got a new client Cherno from, I gotta hide my IP address, but it's got my external IP address here. Hello. There we go. Hello. Let's try do another client. I'll connect as yarn. Okay, we're in. So if I say hello, we'll see it here. Hi, my name is Cherno. Takes a while to appear here, so I think it doesn't post it here immediately. It actually sends it to the server, waits for it to receive its own message again, which is a bit weird. All right, and then you can just send exit to disconnect. Cherno got upset. And then Cherno's out, and yeah, I mean, look, it seems to work. It's pretty simple. I like the fact that this doesn't actually use external libraries. It obviously uses like operating system APIs for the actual socket stuff, but it doesn't actually use any like third-party, you know, libraries from GitHub or anything like that to do all of the connection stuff. That's pretty cool. I think that definitely makes it quite interesting and quite a cool example maybe for some of you who want to learn how to do this stuff kind of at the lowest level, or at least without like, you know, external dependencies. Okay, so now let's have a deeper look at the code. So we'll start maybe with the client. This is the client. I want to quickly say that using printf is an interesting choice. It really doesn't matter, especially for something like that. But since we are in, I don't exactly know what version of C++ we're using here. I mean, just looking through the code, like we're using std format here, which is C++20. So we're at least on C++20. I think since this is quite modern, I would probably try and start using the print API. So instead of printf, you can just use std println. That way you also don't need that new line character. I don't know if this project is C++23 or not, but I did talk about this whole like new way to print in C++ in a video, which I will link up there. Obviously not a big deal. I don't want people to get hung up on like logging or printing things to the console. It's sort of like pretty trivial. You can use whatever you want. But since there does seem to be some effort here to use more modern C++, I'd probably, you know, trend towards that direction. So we have some string views here, which take in all of the different arguments. I think this is pretty cool. It's good to use string views because these already do exist over here as char pointers, and we just kind of need a way to like use them in maybe a slightly nicer format. We could pass them around as char pointers, but it's obviously a little bit more C++-y to actually wrap them in an object that's going to contain some more information, such as the length of the string, which string view will do. The downside of just using string, by the way, is that all of this data is going to get copied into an actual buffer inside string, whether it be dynamically allocated or, you know, small string optimization. So it's just a kind of like a stack allocated buffer. It doesn't matter. The point is we're still actually copying this non-mutable sort of data, this like data that we're just trying to read into its own like object and memory for no reason at all. So string view is definitely the correct thing to do here, and I'm happy to see that. We're starting up 2 threads. It's interesting that this stuff's happening in main because there's this thing called like client room.cpp and hpp, which is kind of like, this is almost like, I mean, I see this as like the client layer, and the server layer is like the main meat of like what the client's actually doing. And in fact, it makes sense because the class name is actually client. So the file is called client room.cpp and server room, but it's just called server and client. So I would expect the client and the server to probably set up its own threads instead of, you know, having the main function go and grab like a pointer to a function inside the client class out here and start up that thread here. You know, instead I just do something like client.start, and then that would actually start these 2 threads inside the client object. But anyway, it looks like the constructor probably doesn't really do much. Oh, it does a lot actually. I keep commenting stuff out for some reason. Oh, it's because there's like this button here to comment, right? Interesting. It's also weird that like, you know, we're using an initializer list to set these things, because that, to me, that kind of communicates almost like this is just a struct of data. Let me just list like some variables here, and that's what the structure is going to contain. But that's not what's going on. We're actually going to be calling the constructor that takes in these 3 things. So I don't know. In that case, I mean, honestly, just stylistically, I guess I probably wouldn't use curly brackets. I would just use normal parentheses like this and create the client that way. Kind of the same over here with these threads, like just use parentheses. I think if you want to use them like for things like this, it's fine, because even though this is also going through a constructor, it's almost like you're setting it to this, like the semantics is kind of there, but this is doing like a whole heap of things, and it makes more sense just to my brain, I guess, to use parentheses here just visually. But it is interesting, and I haven't thought about it too much before, so leave your thoughts in the comment section below. Okay, and then we start up these 2 threads. So the client itself like seems to do some stuff. Like, I mean, it's even connecting to something here. Right, so we're using this sock API, which is inside sock wrapper, which is inside like this utilities thing, which I'm guessing like these files are probably compiled as part of both the server and the client. And this util section is like kind of our core networking library probably that actually uses the system networking API to, for example, connect. So this equals connect, which is part of socket.h, which you can see is part of the GNU C library. Again, we've got this curly bracket obsession instead of just writing equals like this. Don't get me wrong, there are definitely some reasons to use curly brackets when like setting or initializing variables, but I would just write equals here. So it's interesting to me that the constructor is actually doing the connection. I feel a little bit uneasy with that. So we do the connection there, but then we start up another thread, which is going to be, there's two threads. There's a send thread and there's a receive thread. Both of those are started, of course, from here. So they run concurrently. And then, I mean, one of them might as well run on the main thread because the main thread does nothing but waits for these two threads to finish. So the main thread is just dormant, you know, waiting for these two threads to do their things. But the receive thread is just going to, as long as we're not shut down, it's just going to keep polling this. Is it going to do any kind of waiting? So if it receives nothing, it's just going to continue. It kind of seems like it's not like, so what does poll do? Maybe this will sleep though. Yeah, there's a timeout. So hopefully this actually sleeps. It's really important when you have sort of polling loops, when you have just while loops that run over code again and again and again, that you obviously manage the frequency of that running, because it's really easy, obviously, to just like write a while loop that, you know, the CPU is going to execute that as fast as it possibly can, which means you're going to max out like 100% CPU usage on that core or thread, and you're effectively taking up like all of the resources of that section of your CPU for no reason at all, because you're not actually doing anything. So whenever I see any kind of while loop that is polling, that's waiting on some information, and in the most likely case, it's not actually going to receive it, you need to make sure that you're sleeping. You need to make sure that there's some kind of suspension happening there, and that it's not just like running at full steam ahead, unless you want it to, which might be valid for some cases, but this is not it. Again, there is like a timeout. Timeout's usually how long it's going to, I guess, poll internally is going to do something, and then if it doesn't receive, it continues and then goes back here. I don't know enough about how like all of this API stuff works, so my point is just make sure that you consider that, obviously. Then we have a lock guard over a mutex over here to make, ooh, okay. Right, so the immediate thing that jumps out to me is that like, so when you do any kind of locking obviously means that other threads cannot access anything that they might want to obtain that same mutex lock on while it's already locked. So whoever gets there first and locks it, if someone else comes, another thread comes, they have to wait for it to become unlocked before they can lock it and thus start doing whatever they want with it. Because of that, you obviously want to reduce your time locked. You want to make sure that you're locking for the bare minimum time required. So when I see code like this, which this lock guard is, this is like an RAII thing to basically lock this mutex, just by essentially calling console mutex.lock until the very end of this scope, obviously, because it's an object over here that gets created like this, which means the object will die at the end of the scope, and the destructor is going to effectively call console mutex.unlock, and then we're going to get that mutex back so that another thread can lock it. So since it's encompassing this entire scope, my first thought is, does it need to? Is it actually important for us to lock all of this operation behind that mutex? Because usually not. Usually it's maybe like one of these things, one of these variables is being used by potentially multiple threads, and therefore we need to kind of synchronize access to just that. But it's obviously very easy to just throw a lock over everything, but then that means that the other thread's just going to stall. It's just going to be waiting for its turn to actually use that, even though you might have locked it arbitrarily. And that's because, of course, we don't lock over a particular set of data. Like, we've created this arbitrary mutex. I should probably make a little like video on how to do this in the first place. But anyway, we've obviously made this object that doesn't mean anything. It's just called console mutex, and we just use it as like this subject to lock. And then that just means that nothing else can lock it while we've have it locked. It's not like we're specifically doing this over socket poll or text box or any kind of, you know, shutdown or any kind of data. We're actually just arbitrarily locking console mutex. It means whatever we want it to mean. And so therefore it's important for us to restrict that and contain that as much as possible. Anyway, the receive thread is going to, once it does lock that, it's going to, I guess, try and receive stuff from the socket. I'm not going to focus too much on the actual API here because I'm really not familiar with it. It looks fairly okay. I mean, we are passing in kind of a raw buffer here. I'd probably make this like a higher level construct so that it's not just like a pointer and a length being passed as two separate parameters, even though that's obviously what it comes down to, but I want a little bit more safety around that. It does look like we're going through all of this and we're kind of appending it to that one buffer that gets passed in, which probably has some kind of max length, which is probably quite big. It might even be like some sort of scratch buffer. I mean, in this case, it's just a uint 16T that we're casting, and so it's only going to be that big. But then here, for example, is, right, okay. So this is the length of the string, and then it's going to allocate just enough space for this. But so this actual data, what is this? This is an array which has a max, this is for the username, max username size. And then there's a max message size over here, which is 1024, right? So these are basically the buffers that get pre-allocated and just contain the maximum possible like message or username that we can have. And for usernames, it's 30 characters. For messages, it's 1024 plus 1 probably for the null termination character. The problem here is that like this would kind of make sense maybe if it was like a one-off thing, but this is a constant. It's a constant object that's being created. So chat message, for example, is created every single time. Now, it's obviously not heap allocated. It's an STD array. It's not allocated on the heap. There's no like constant transient allocation, deallocation happening. But I don't know. I still feel like I would probably design some kind of scratch buffer. That way you also wouldn't have to worry about just having a message size of like 1024 characters. It could really be as long as you want it to be, because if the scratch buffer is too small, it could, you know, double in size. It could reallocate. I don't know. When I look at this stuff, I feel like I always want to like separate the actual chat message, which might contain like an eventual std string or something that contains the message, from just like a buffer that I use to receive data, which is, you know, something that I can obviously reuse time and time again, but also it can receive any data I want, and then I'll kind of take that, process it, format it, transform it, whatever, and then set it into like its final kind of resting place. Okay, let's have a quick look at the server as well. So again, inside server main, we're also setting up the threads over here in the main function, but then having them start functions inside the server class for some reason. Very, very similar over here. We've obviously got like this connection thread and the chat thread, client polls data and the size. So client polls. So we've got a vector of client polls, which is poll FD, which is a data structure describing a polling request. And then we've got client usernames over here as well. So this is all about client data, right? I kind of feel like this should be like here maybe? I mean, again, I don't like locking large areas, but I feel like surely this stuff gets created inside the other thread, which, because it's called connection thread, right? So connection thread, then we've got this lock here. And then, yeah, like here's our new client. And then here's client usernames in place back. Client polls, here it is, client polls in place back. So client polls and client usernames are effectively guarded by this, because we're obviously emplacing back into client usernames. We're adding to that data structure. But then over here, we're reading that data structure without the lock over it. So I don't know if this is a bug, considering that like it's, I mean, okay, it is a bug, but what I mean is like, if this is like a typo effectively, because why is this line under this line? If clearly you're basically locking everything that you possibly can, it just seems like out of character to, you know, skip a critical line here with the lock. Yeah, so obviously make sure that any data that you have between threads is locked, is synchronized, is like not just free to be either read or written without any kind of like lock or sync point. That's kind of like multi-threading 101, just to make sure that you don't have any like data races or any weird behaviors that can come out of that. A really frequent way to make sure that you are minimizing the scope, I guess, of what is locked, because we might need to repeatedly use client polls or client usernames within this function. However, we also want to not lock it so that it can be open to more clients joining in the meantime. And a really common way to deal with that is just to simply copy that data structure, to just copy that collection into something that is effectively thread local or local to this scope temporarily, potentially. And then once you've done that copy, you can unlock it and proceed with essentially two different instances. One that is going to be processed in this current function by that one thread, and then the original one that's going to be added to potentially by that other thread. So just make sure that you're thinking about stuff like that. Of course, multi-threading is a complicated topic and it's hard to get right, and there's a lot of optimization within it, but this kind of application, this kind of project is like honestly one of the most perfect ways to actually perfect kind of that art of multi-threading, or at least like the basics of multi-threading, which are kind of at play here, but not done entirely correctly. The other thing that's kind of a little bit odd to me as well is that there's a lot of printfs happening with strings being printed. However, the way that usernames are stored, So username is like this struct, remember, that we looked at, that has an array of this particular like max possible username size. It's got a length here, which is length of the username, which is important considering we don't know how long it is, because this array is going to be 1025. Actually, sorry, that's 1025. This is 30. So 31 chars long, but we don't know where the end is. When we set it, we need to make sure that we like clear it all maybe to 0 so that it's like null terminated, and then maybe we would know where it is. But obviously we have the presence of an actual length integer. So that defines the size, and this is just a buffer of memory. So therefore when we print, we're not actually specifying any kind of size here. We're just printing that data buffer, which may or may not be null terminated. Anyway, it's entirely possible that this is fine, assuming that every single time you set this buffer, you actually like mem set it to 0, or just make sure that, you know, you clear it to 0. It's like all those characters are null, but it just looks a little bit suspicious, and I'd just be concerned whenever I see, you know, data buffers directly being printf'd as strings, especially if I then realize, you know, they're just like an array. Yeah, it's crazy how long I'm scrolling down, and it's just all lock guard. It's just all locked. So yeah, I would revise that. Okay, and then client poll. So client polls must be like, because we're iterating through all the client polls, and then all the received messages, we're effectively relaying them to all of the connected clients. So I guess this client poll thing, because again, I haven't used this API before, but I'm assuming that like this is effectively like a client ID, because we're sending into that FD, which is a file descriptor. That's where we're sending. That's the socket that we're sending to, essentially. So in other words, yeah, this is like client polls is like all of our connected clients, but so is client usernames, because obviously these are all of the unique usernames. So why are these not together? Why do we have two different vectors for this? We should have a struct that has, you know, a username struct inside it maybe, and a poll FD, because that way we obviously link all of our client data in one kind of data structure instead of having two. Because the other thing is, I guess these have to somewhat line up. I'm expecting that we, you know, if we want to relate a username with an actual poll FD, a poll file descriptor or whatever, one of these client poll objects, so that we actually have our client ID correlated with our username, then obviously they're in a vector, so the indices have to match. So yeah, I would definitely combine them into one struct. You could also maybe have a map of like poll FD to username, or, you know, int like as an ID, or UN64T or whatever you want, into a struct of this and this like together. But yeah, having two different vectors for this is a little crazy. And then yeah, like with these, you know, I really would cut out the curly brackets for all of these objects. All the C++ objects, they have default constructors, so it's gonna do nothing. Over here, this is just a struct of data, so there is a huge difference between doing this or doing that. This is just going to be completely uninitialized, whereas this is going to be initialized. So basically the integer will, well, all of these integers are all going to be set to 0 versus random numbers, because uninitialized memory. So in this case, 100% matters, but for the C++ objects, you don't need to do that. If you want to, that's fine. You know, if you want to be consistent, make sure you don't forget, but you didn't do it here, so you weren't consistent. And see here, like this is another example of why I was saying that like you need to make sure that you link them together, because if a client disconnects, then we have to erase from both client polls and usernames. And you can see the way we're doing that is almost a little bit dodgy, because we're relying on the index being identical, which it will be as long as we are kind of, I guess, adding and removing clients in the same fashion. But it's still kind of, at the end of the day, they're just incrementing indices of a vector, and having to do this operation twice instead of kind of just do one erase is also a little bit inefficient. So yes, I would definitely combine those two into just one vector or one map that contains all of your client information. Anyway, final thoughts are, this is a working project after I fixed the compile errors due to the refactor. This is a working project. It worked on the server. It worked across several clients. The code doesn't use any like external dependencies that aren't part of the platform, the operating system. It obviously would be nice to have this be cross-platform potentially, but as like just a little like Linux networking exercise, I think this is a pretty pretty good job. I think it's really important for you now to take this and kind of refine it and make sure that you use it as your testing ground, as your sandbox to learn multi-threading and networking properly. Just like polish it up with what I was saying with like the mutex locking and the race conditions and all of that stuff, because getting it right in such a small, concise, clean project is gonna make your life like a lot easier for the future. What did you guys think of the code? Leave a comment below, or you can discuss it on the Code Review Series channel on my Discord server. If you guys want me to review your code, send it into chernoreview@gmail.com. That email address and some instructions will be in the description below. Thank you guys for watching. I will see you next time. Goodbye.